Now here we depict a curve with 2 points. This point we'll regard as being the point corresponding to some x coordinate along the x-axis. We sketch the segment from this graph point to a graph point further along the curve, and we could find the slope of this. If this is our x plus delta x point, then this would be our x plus delta x, f of x plus delta x point. But what we want to show is that as we move along the curve closer and closer to this point, this segment has a slope that approaches the segment whose slope approaches that of the tangent line at this point, the line tangent to the curve at this point. So if I draw a point, let's say here, there's the segment. If I draw a point here, then I get a segment here. And if I draw a point any closer, the segment is actually going to pretty much lie inside the chalk line of the curve and won't give us any additional information. So the idea is, as we come closer and closer to this point along the curve, these segments, the slopes of these segments, approach the slope of the tangent line. So this segment has a slope that's not all that close to that of the tangent line. This segment is closer, and this third segment is much closer. And if we continue drawing segments, the slopes of those segments will get closer and closer and approach the slope of this tangent line as a limit. Okay, now this point could be an x plus delta x, f of x plus delta x point if delta x is this big. And this point would be x plus delta x, f of x plus delta x point if delta x was this big. And this point would be that point for delta x this big. So what we have here, I could regard these as x plus delta x points for smaller and smaller values of delta x. And then I can imagine that those values of delta x continue approaching 0, so that these points approach this point. Now, no matter how close the point is to this point, we're still going to have a little fundamental triangle with a slope. And as delta x approaches 0, that slope approaches that of the tangent line. So we can say that the slopes, f of x plus delta x minus f of x divided by delta x, approach the tangent line's slope as delta x approaches 0. Now, of course, f prime of x, the derivative of x evaluated at the point x, is defined to be the limiting value of this expression as delta x approaches 0. So it follows that the slope of the tangent line is f prime of x. So if we want to find the slope of the tangent line to a graph at some point x, we simply take the derivative, assuming we have a function that's sufficiently well behaved that we can take the derivative. We take the derivative and evaluate it at that value of x. And that gives us the slope of our tangent line. It identifies the slope of the tangent line with the derivative function.